Hello everyone. So in this lecture, we will look into one of the most commonly used and very famous distributed file system called network file system. So the reading for this lecture comes from Common Book, chapter 48. Optionally, you can read 47 and 49 as well. So network file system is the first commercially successful distributed file system. It's one of the file systems that's widely used today, and it is known for its robustness and decent performance and the properties it provides, especially regarding crash recovery and resilience, are very, very good compared to other distributed file systems. And there are many versions of network file systems that have been proposed, and depending on the configuration of the server, one of these versions will be used. So the basic at the bottom of network file system NFS. So we have remote procedural calls that are used to communicate between server and client. So remote procedure calls. If you have like taken high level programming language courses such as Java, you must be aware of remote procedure calls. So remote procedure calls are similar to regular procedure calls, like regular function calls. But the only thing is the function or the code of the function stays in another machine. So any machine now that needs to make a remote procedure call has to now pack all the arguments into a network packet, send the packet to the remote server, and remote server will unpack the arguments and execute the function and pack the result back and send it to the client. So this is like very high level overview of how remote procedure call works. And at the heart of NFS, remote procedure calls plays an important role that is used uh, and RPC is used to communicate between network and client. So on the client side, client just provides a transparent access to the NFS file system. So client exposes regular file system to all the user applications. So user just access the file system as if user is accessing regular file system. And under the hoods, client actually converts these file system operations to remote procedure calls. Okay. And the way it does is there for each file usually similar to inode, there is a vnode that is maintained for each file and which actually translates all the file operations on each file to corresponding uh, RPC calls. Okay. On the server side, server is very simple. Server just serves the RPC calls. Okay. Server just waits for the RPC calls. Whenever an RPC call comes in, it unpacks the arguments, runs the procedure, and returns the result back. So server in case of NFS is stateless. By stateless, I mean server doesn't maintain any state for any of the clients. Okay, so every request is independent from other requests. So there is a similar, for instance, like if I've visited some websites, websites are mostly stateful because you log in, you get a token, and server remembers that you log in, right? So that is a stateful service. In case of NFS, it's stateless. So every request is independent, and this also makes the server design easy because server now don't have to remember anything about the client, and server now can scale easily with the number of clients because since server doesn't maintain any information about the clients, it doesn't matter how many clients are using NFS, the performance will not be degraded much. And another implication for statelessness of server is all the data, all the modified data now must be committed to the storage before sending the response because server is stateless. So since it doesn't remember any state whatsoever, any request that comes and whenever before server sends a response back, server needs to make sure that the data is already committed to disk. Okay? So it cannot do any page caching, none of the caching because client thinks that the server is already committed or client might die after one request, right? So server should always commit after each request. So in order to make it fast, server often use like SSD in or NVRAM to improve performance, so that the, the performance of the disk is fast. So in terms of interactions, you can see that application interacts with, on the client side, application interacts with the kernel using regular system calls. And the file system layer in the kernel is one that actually translates the system calls into remote procedure calls to the file server. Okay. And note that there is a translation that happens in the kernel side. And the interface seen by the application is different, and the interface that is used by the kernel to the file server, that's different as well. So NFS, when NFS was designed, it has four main objectives. The first one is machine and operating system independence. It was designed so that uh, clients and servers that belong to different operating systems should be able to use NFS. The other objective is transparent access. Like remote files should be accessed exactly in the same way as if the files are accessed, as if the files are local files. Okay? Application should not be worrying about where the file is located. So it should have transparent access. And fast crash recovery. So in an unfortunate situation, when a crash happens, NFS server should come back immediately. Okay? And it should provide a reasonable performance. We don't expect it to provide like super amazing performance as if it's a local file system. But on the other hand, we don't want it to degrade very badly. So we want a reasonable performance uh, from an NFS. Now, first, in this part, we will look into transparent access, how network, like how NFS provides transparent access to the files. So when we are naming anything like any entity, file, or process, whatever. So here we need two properties that makes the naming transparent. One is location transparency and location independence. So location transparency means in case of files, the name of the file doesn't reveal the file's physical storage location. So irrespective of wherever the file is stored, the file location, like the file name, you cannot figure out the actual location of the file by looking at the file name. So that is location transparency. And location independence is the name of the file doesn't change with the file's physical location. So let's say name of the file is foo, irrespective of where the file is located, the name stays the same. Okay? That is location independence. So location transparency allows users to use the file names without worrying about physical location because the name doesn't change. Like the names, you cannot figure out the physical location from the name. And location independence allows the file names not to be changed when the storage actually changes in the back. So there are two common naming schemes that are used to access NFS files. The first one is using the machine name and the local path on the machine on which the file is located. Okay, since uh, you have, you could have like, since the file is located on the server, so if you want to access the file on the server, you can use the server name and the local path within that server. An example, for instance, let's say I want to access hello in the temp folder of ECE grid. I could just use the machine name followed by the file name. Okay, but note that this naming is neither location independent nor location transparent, because from the name I can figure out where the file is located, and when the file location changes, the name changes as well. Okay. The other commonly used approach is to attach remote directories to local directories. So you must be aware of mounting, right? So we have seen how we can mount, for instance, we have mounted local disk onto a local folder in our previous lectures. So similar to that, we can mount NFS file systems onto local directory. Okay? Now you can users can access local directory as if according to the users, the user is accessing local files, but under the hood they would be translated to actually remote procedure calls. Okay? So the second naming scheme is the one that provides transparency. After the initial mount command, everything, all the accesses that we make are transparent or location transparent. So how to implement transparency? Similar to all the other problems that we have seen before, we just provide a level of indirection. And by this time, you must be aware of various places in which we have used this concept of indirection, be it page tables, uh, flash translation layer, or even even caches. Like, yeah, just think about like places where we use this nice principle of indirection. Basically, we provide a additional layer of indirection, and that provides a lot of properties. One property is transparency. So we just provide a layer of indirection. So what happens is under the hood, on the client side, so the client provides in case of Unix. So Unix, we have virtual file system that is actually the common wrapper for all the file systems in Unix. So Unix provides a virtual file system, and depending on the implementation of underlying file system, uh, the actual function calls or the actual methods used to access the files changes. For instance, if it is a local file, we just use regular system calls. In case of network file systems or like other file systems, maybe like SSHFS, that's a file system implemented over SSH, by the way. So you must be aware of SSHFS, right? That's also a file system which is implemented through SSH. So there, again, we expose the interface exposed is virtual file system interface, where the regular system calls will be supported, and then they will be translated to actual calls to either RPC in case of NFS or SSH commands in case of SSHFS. Okay. So in the next part, we will look into crash recovery mechanism of NFS.